Hello students, we're going to analyze motion in a horizontal circle in this session. A horizontal circle motion can be executed in this way, in the way of a conical pendulum. So we have a pendulum, a string tied to a wall at this point, and there is a mass, a bob of mass m, hanging like this. And this bob is whirled round and round. So it goes, so here is the string and here is the bob. The bob is going like this. The bob is going like this. Okay. So that is the horizontal circle we are talking about. And the angular velocity is given to us. It is omega. Since there is a string attached to this bob, there's going to be a tension also. Let's call that tension T. Let us assume the radius of this horizontal circle to be r. Let us find out T in terms of quantities like theta, where theta is the angle that string is making with the vertical. What we'll do is we'll balance forces. Since there is no motion in the vertical direction, we can say that this mg must be balanced by one component of the tension. And what would be that component? Since this is theta, we can say this is theta. This would be T cos theta. So we can say that mg is equal to T cos theta. This is one of our equations. Now, for the next equation, we're going to look at the circular motion. This bob is going around in circles. So this bob is moving around in circles at a constant angular velocity. So this is just like uniform circular motion in a horizontal plane. Uniform circular motion is executed when something is providing the centripetal force. And that something, this centripetal force, is actually provided by the other component of tension, which is T sine theta. So this is equal to T sine theta. This component is T sine theta. Okay. And we also know that Fc, or the centripetal force, is represented in terms of omega like this. M omega square r. This is equal to T sine theta. So this is our another equation. So let's say if tension is unknown and theta is unknown, we can use these two equations to find these two unknowns. Or if theta is given, omega is unknown and tension is unknown, we can again use these two equations to find the answer. Okay. So this is the generic treatment of a horizontal motion, of a circular motion in a horizontal plane. But sometimes questions and books will simplify this horizontal motion, and they would ask you that, they would tell you that the motion is happening something like this, something shown here. Now think about this. Is this practically possible? Can you rotate some object in perfect horizontal circle? So, is this practically possible? Think about it. There is a force mg always pulling this mass down. Is there something which is balancing this force? You'd find here in this scenario, there is no such thing which is balancing this force. So this situation is not practically possible, but it's an approximation. Okay, we say that suppose there is a motion happening like this, then we do not care about the vertical balancing of forces. We only focus on the horizontal forces. So let's focus on horizontal forces now. Since this bob is going around in circles, let's say with an angular velocity omega, there must be a tension which is providing it the necessary centripetal force, which is m omega square r. And this is the only equation that is needed to analyze this kind of simplified circular motion in a horizontal plane. In previous year's NEET exam, we have a question exactly based on this. So let's solve that question and see how this formula helps us to get the answer. So pause this video, take a look at the question, and then try to solve it first, and then look at the solution, okay? Okay, so let's solve this question now. This question says a bob is whirled in a horizontal plane by means of a thread or a string with an initial speed omega revolutions per minute. The tension in the string is T. Initially, the tension is T. So it's a very similar scenario that we had in the diagram where there was a bob which was going around in a horizontal circle. It's given that initially the tension is T when this is rotating with omega. And they're asking, what if the speed or the angular speed becomes 2 omega while keeping the same radius? What would be the tension? How much will the tension increase? So we just saw that this tension was given by m omega square r. If radius remains the same, mass of the object remains the same, and only omega is changing, omega is becoming twice. So what would be the new tension? The new tension would be m, the new omega whole square r. And the new omega is 2 times the initial omega. So let's see how much is the tension increasing. 4m omega square r. And m omega square was T. So we can write 4 times T. So the new tension is 4 times the original tension. So that's the solution. It would be answer option number